All right, welcome to 9.5 alternating series. So we're going to learn one more test today, the alternating series test. But first we have to identify what is an alternating series. So an alternating series contains -1 to the n, -1 to the n plus 1, or even -1 to the n minus 1. Okay, so it typically looks like this. The series from whatever value of n to infinity of -1 to the n times this a sub n, okay? So the alternating series test is going to converge if there's kind of two scenarios that we have to show. We have to show the limit as n approaches infinity of a sub n. So that's this portion of that series, okay? We're not worrying about the -1 to the n portion, okay? When we're taking that limit for the alternating series test. Also, we have to show that the terms are decreasing, meaning the next term is smaller than the previous term, or the previous term is bigger than the next term, okay, for all n, all right? Now, before we kind of talk about and apply the alternating series test, remember that nth term test, okay? So our nth term test is we're taking the limit of that sequence. Now the nth term test does include this -1 to the n, or that alternating portion, okay, if we have an alternating series. If it doesn't equal 0, it diverges. So we always want to start with that nth term test, okay? If it's an alternating series, and it converges, we'll have to talk about conditional versus absolute convergence. And I'll talk about this in just a little bit, okay? But first, let's get to our first example here, okay? Again, don't worry about this conditional versus absolute yet, okay? So if we have this series, -1 to the n minus 1 of 2n over 4n squared minus 3, our first goal is to check out that nth term test, okay? So remember, the nth term test does include this entire, we're taking the limit of this entire quantity here, okay? So if we were to go through this, use L'Hopital a couple times, we're gonna end up getting, we would say plus or minus 0 because of this alternating portion, but it's 0. So therefore the nth term test is inconclusive. So we have to go to, or we can check the alternating series test, okay? And we'll take it a little further next time, but if we just apply the alternating series test, again, we need to prove those two things. We need to show that the limit of the a sub n part, so that's the 2n over 4n squared minus 3, we have to show that this equals 0. So as we go through L'Hopital a couple times, right, we use L'Hopital here, we're going to end up getting 0, okay? So therefore, we met the first criteria, all right? The limit is 0. Now we have to show that it's decreasing. So there's a few ways we can show this, but since there's multiple n's going on here, it's going to be easy to let this a sub n be represented as a function. So f of x equals 2x over 4x squared minus 3, and now we find the derivative. So don't forget that quotient rule. Low d high minus high d low, all over low low, okay? And as we work through it, we're going to end up with our first derivative being -8x squared minus 6, all over 4x squared minus 3 squared. Well, our denominator will always be positive because it's a quantity being squared, and our numerator will always be negative for any x value greater than 0. So therefore, we've met the criteria that this is a decreasing series, okay? So because we met those two criteria, we can say by the alternating series test, that series converges, okay? Now, we talked about if the alternating series converges, we need to be able to talk about conditional or absolute. Now, let's quickly look at the next page to talk about what is conditional versus absolute convergence, and then we're going to come back to finish this portion and talk about this aspect of it. So really quickly, let's go to the next page. Okay, so moving forward, what we're going to do is we're going to follow the process. We're going to follow the steps, okay, the process for converge or diverge. So if we're going back to this example here, we would start with our nth term test, which we already said is plus or minus 0, which is inconclusive. So then we have to figure out conditional or absolute. This is where we look at the absolute value of that series, okay? So by looking at the absolute value, we're really looking at this series here. So what's the best approach? Well, I chose the limit comparison test to see if this converges or diverges. So I'm going to let Bn be 1 over n. So then this series, the series of Bn, is a diverging P series. It's harmonic. Okay? So then applying that limit comparison test, remember the limit as n approaches infinity of a over b, is really equal to the limit as n approaches infinity of 2n over 4n squared minus 3 times n over 1. Okay? So cleaning that up, using L'Hopital a few times, okay? We're going to get this limit to equal 1/2. And remember the criteria is it has to be greater than 0. So, therefore, this series diverges by the limit comparison test. But remember previously by the alternating series test, okay, so that would be the next step, we get it to converge. So since it diverges by the limit comparison test but converges by the alternating series test, we would call this conditionally convergent. Okay, let's move on to this next example, example 2. Okay, again, we have an alternating series, but we always start with that nth term test. Okay, so taking the limit of that entire series, we would end up with plus or minus 1/2, because this guy is going to continue to go to be plus and minus, all right, but this portion goes to 1/2. So that doesn't equal 0. So we're done. By the nth term test, this entire series diverges. Okay, so absolute versus conditional convergence. So we would start by saying if the absolute value of that series converges, then the series itself converges. So then AN is called absolutely convergent, okay? If the absolute value of that series diverges, but the whole series converges, then AN is called conditionally convergent, okay? So now I want to zoom in a little bit on the process, the steps that we're going to follow to prove whether something converges or diverges, and then if it's an alternating series, does it conditionally converge or absolutely, okay? So step number 1, the process for converging or diverging, we always start with the nth term test, okay? Unless you can see that it's a geometric or P series, okay? So nth term test, there's 2 choices. It either doesn't equal 0, and if that's the case, we diverge and we're done. If it equals 0, we're inconclusive. So then we have to go to step 2. So step 2 is we can use any other test that's available, right? And what we're going to do first is we're going to look at the absolute value of that series. So we're going to look at the positive portion. So if it's an alternating series, we're going to forget about the -1 raised to the n portion. All right, so if we're using those tests and we converge, then it's absolute convergence, and we're done. If we diverge, okay, and it's an alternating series, if the alternating series converges, it's conditional convergence. If the alternating series test diverges, then the whole thing diverges. So make sure you've got this down. Now we're going to go back to that first example on the previous page to talk about conditional versus absolute convergence. If the video was not properly cutting back to the previous example, I would go back over that example, make sure you understand absolute versus conditional convergence, but we're going to move on from here. All right, so talking about some rearrangement before we go to these next examples. Okay, finite sum. If we have a finite sum, rearranging the terms doesn't affect the sum. So just kind of putting certain ones first and certain ones last, it doesn't matter. Infinite absolute convergence. Okay, rearranging does not affect the sums again. Okay, so if it converges from the get-go, it's going to converge. It doesn't matter. But conditionally convergent, the rearrangement of certain terms can certainly affect the overall sum. So if it's, remember, conditionally convergent would mean that it diverges for the absolute value, but it converges under the alternating series test. So there's different aspects. If we rearrange things, okay, that does affect the overall sum. All right? But let's look at a couple more examples of just going through the process using our process for converge and diverge. Okay? So if we're looking at this series, okay, I recognize it's an alternating series test, but I'm going to start with the nth term test. All right, so when we take the limit of the entire thing, we get plus or minus 0, or 0. So this is inconclusive. So we have to move to the next step. Now we're going to look at the absolute value of this series. So we're going to omit this -1 to the n minus 1 portion. And we're just going to take or figure out if this series converges or diverges. So what we should recognize is this is a harmonic p-series, which diverges. So now we have to go to the alternating series test. Okay, so remember with the alternating series test, there's two parts. First part, I have to take the limit as n approaches infinity of the an portion, that 1 over n. And that equals 0, so we're good to go. All right, now I have to prove that it's decreasing. So I need to prove that the previous term is bigger than the next term. So 1 over n is bigger than 1 over n plus 1. Cross multiplying, we get n plus 1 is greater than n. Subtracting n's from both sides, we get 1 is greater than 0, which is true. So it is decreasing. So therefore, it converges by the alternating series test. Okay, but what's our conclusion? Well, since the absolute value diverges, because it's a harmonic p-series, but it converges by the alternating series test, we call it conditionally convergent. Okay? Let's take a look at this next term, or this next example. Again, I see that we have an alternating series. I do my nth term test, okay? And kind of cleaning things up, all right? Meaning multiplying the denominator out. Using L'Hopital, or actually, yeah, using L'Hopital a couple times, we end up with the limit equaling plus or minus 1/4, which is not 0. So hey, we're good. Therefore, it is divergent by the nth term test. This last portion kind of steps away from converging or diverging series, and we're focusing solely on alternating series remainder, okay? So if a convergent alternating series satisfies the condition that the next term is smaller than the previous term, then the absolute value of the remainder involved in approximating the sum S by Sn. So Sn is the partial sum, S is the overall sum, is less than or equal to the first neglected term an plus 1. So we have this formula here, okay? The absolute value of the overall sum minus the partial sum is equal to the absolute value of that remainder, which is going to be less than the value of that so-called term, that next term, okay? Now, a little side note that I have. For convergent alternating series, this is saying the partial sum, Sn, can be useful to approximate the overall sum of a series. That's kind of what it's saying. Is, okay, well, if I just add up a certain amount of terms, I can use that to approximate the entire sum of the series, okay? So let's look at this example here. How many terms are needed to approximate the sum of this series with error less than 0.005? So there's kind of two parts. After we figure out how many terms, then we'll provide an estimate for the sum, the overall sum, using a partial sum. So the first thing I'm going to do is I'm going to zoom in here. Okay, so our series is this guy over here. Okay, and that's what we're going to plug in for. Now I want to find the value of each of those terms, and what I want to do is I want to find the first term that is less than this 0.005. Okay, so as I'm plugging n into that series, when n is 1, we get 1/4. Okay, 1/4 is 0.25. 0.25 is not less than 0.005. When n is 2, we get negative 1 over 32. Now, if I'm just looking at the absolute value of that, 0.03125 is not less than 0.005. Okay, so when n is 3, we get 1 over 192. That's 0.0052, okay, which still is not less than 0.005. If I go to the fourth term, negative 1 over 1024. Again, just looking at the absolute value of that, we get 0.009765. This is less than 0.005. So this is going to help us figure out some things. This right here, this n equals 4, this last term, negative 1 over 1024, this is our a sub n plus 1, okay, which is a 4, okay, but n is going to be 3 because 3 plus 1 is where we get 4 from. So the n is 3. So what that means is I'm going to use the third partial sum, s sub 3, okay, to approximate the overall sum of this series, all right? So the first part of the question asked how many terms? Well, 1, 2, 3, okay, because the fourth term is where I am less than this 0.005. That's where my error is, okay? So we need 3 terms. So that what that means is we're going to be using S3 to approximate the sum, the overall sum, okay? So using this formula from up above, this guy here, and kind of looking through it over here, okay? So now I'm going to zoom in a little bit so that Rn is less than or equal to an plus 1, the absolute value of that, okay? And we know Rn, we know n is 3, okay? N is 3, and n plus 1 is 4. So the R3 is less than or equal to A4, all right? Okay, so using this kind of formula here, we know, I should say this should be an equal sign, not a less than sign. Okay, so what we're going to do is we're going to do our little substitution. The absolute value of S minus S3, because we want the sum of those first 3 terms, that partial sum, all right, is equal to that remainder, okay? And this is going to be less than that A4, that last term, the absolute value of it, okay? So we're just looking at 1 over 1024. So we have this, and now we just have to solve for S. Where does S fall between, okay? So if I rewrite this, dropping the absolute value bars, we can say that S minus 43 over 192 is between negative 1 over 1024 and positive 1 over 1024. Adding 43 over 192 to both sides, we're going to get that the overall sum of this series has to fall between these 2 values, okay? And those 2 values are approximately 0.22298 and 22493. If we were to look at S sub 3, the partial sum, you would actually see that that value falls in between here. So it is a good representative of the overall sum of the series. If you have any questions, let me know.